Now, the Wright Sports Management sells elliptical machines, and the monthly profit from these machines can be modeled by P of X equals negative, the quantity X minus 45, X minus 45, the quantity squared, plus 5,500, where X is the number of elliptical machines produced and sold. Well, you're going to use the graph of Y equals negative X squared and the appropriate transformation to set the window and graph the profit function. Then we're going to answer the question, how many elliptical machines must be produced and sold to yield the maximum monthly profit? And what is that maximum monthly profit? We're looking for the maximum. Looks like the vertex to me. Well, since this is a negative, we know it's going to open down, and here is that parabola graph. The transformation. We know P of X equals negative of X minus 45, the quantity squared, plus 5,500. Well, we know that the 45 is minus 45, so it's going to move it 45 right. And the plus 5,500 means it's going to move it 5,500 up. So that can give us appropriate window. And I have this function graph for us. Now we want to know how many elliptical machines produced and sold to yield the maximum. We want the maximum. We're looking for the vertex, which appears to be about right here. And I can use, this is in vertex form. My Y equals X minus H squared plus K. So H will be 45. How many machines? I need to sell 45 elliptical machines to get my maximum profit, and my maximum profit is $5,500 because that's the K of this equation. Now we want to compare the graphs of kx squared with k equals 1. So that's my regular 1 x squared function. And k equaling 3 will be y equals 3x squared, and k equal 1/3 will be y equals 1/3 x squared. Here's my normal y equals x squared function. Now y equals 3x squared. A is 3, it's bigger than 1, it got skinnier. They say it's a vertical stretch by a factor of 3. Well, let's look. This was 0. This was 1, 1. Look at it, it's 1, 3. So I took the 1 times 3. 2, 4 here would turn into 2, 12, which is going to be up here a ways, about here, but 2, 12. So that's why it's saying it's stretched by a vertical factor of 3. It's gotten taller by 3, which makes it skinnier. This one has a vertical compression, they say, by 1/3. Well, here's my 1, 1 becomes 1, 1/3. 2, 4 becomes 2, 4/3. 3, 9 becomes 3, 3. So that's a vertical compression. It's become fatter by 3. So when we're stretching or compressing graphs, the graph of A of f of x can be obtained by vertically stretching the graph f of x by the factor of the absolute value of A if A is greater than 1. It's stretched, it's got it taller, which makes it narrower. And vertical compressing by if A is between 0 and 1, it's compressing, so it's gotten shorter or compressed, and that makes it look fatter, as we've talked about in chapter 3. Now we're going to compare the graph of y equals x squared and y equals negative x squared. Well, we've actually already done these. So for y equals x squared, and we're going to number this by normally, we will have negative 2, 4, negative 1, 1, 0, 1, 1, 1, 2, 4. Of course, we would have our 3 nines and negative 3 nines. So our parabola, our basic parabola. Okay. And then for y equals negative x squared, I'll 0, 0. Instead of 1, negative 1, 1, it becomes negative 1, negative 1. Instead of 1, 1, it becomes 1, negative 1. 2, 4 becomes 2, negative 4. Negative 2, 4 becomes 2, negative 2, negative 4. So we have the parabola that opens down, which we'd already looked at earlier. So this is reflections across the coordinate axis. If the graph of y equals negative of the function f of x can be obtained by reflecting it across the x-axis. So it was here, here's the x-axis, now it's down. If it's y equals f of the negative x, it's obtained by reflecting across the y-axis. So if I had this to begin with, reflecting the y across the y-axis, would move it over here. So I can fold along and have a mirror image across. Here's a mirror image up and down.